All right, so let's get this started. Welcome to the Terraform Basics for Microsoft Azure live stream. In the next 45 to 60 minutes, I will talk a little bit about, well, what Terraform is, why it can help yourself and your organization to become more successful, and how it perfectly works with Azure. Now, it's very important. This is a session that is really addressed for beginners. So don't expect that you will leave after an hour being a Terraform expert. So this is really covering the basics of Terraform so that you're able to start your own Terraform journey, start writing your own scripts, deploy those scripts against whatever platform you want to use, and then continue to build your own knowledge from there. So if you're expecting like high whatever level deep dive stuff into Terraform, then this is definitely not the right session. So this is about basics. All right, so I'm happy to be here today, and I'm not alone. As you can see, it's myself, Marcel. I will do the presentation, all the live demos, and I'm together with Mirza, and he will take care of the questions. So if you have any questions about what we're presenting, if you have like any generic or general questions, feel free to use the Q&A section in well, on the right-hand side. And we try to answer those as fast as possible during the presentation or maybe afterwards. So the goal is to block maybe 50 minutes for the presentation itself, and then we have another 10 minutes for Q&A at the very end. All right, so one slide about myself so that you know who is presenting today. So my name is Marcel. I'm a Microsoft Regional Director. That's a little bit of a confusing title because well, it seems that I work for Microsoft, but actually I don't. So it's an award that Microsoft gives to people that well, work closely with Microsoft customers and also with the Microsoft well, corporation when it comes to developing new product or extending existing products. I'm also an Azure MVP, so I work a lot with Azure, and that's, let's say, the most time I actually invest. That's talking to my customers, getting requirements, building valuable solutions for them, and of course, infrastructure as code. And from time to time, also Terraform is something we use to build solutions that we then hand over to our customers. I operate out of Switzerland, so for now, it's 5 p.m. in my country. I know it's not that comfortable for everyone that is attending now. I heard of people that had to, well, stay up very long, very late, and people had to get up very early. That's the downside of live streaming, right? But yeah, it never fits into everybody's schedule. So that's sad, but for the ones that are here, I hope you enjoy the next hour. All right, so I speak a lot about technology, especially Azure and well, related technologies at conferences. I blog about it. So also make sure that you follow my blog and you follow me on social media if you want to get updates from time to time. All right, so one slide about this specific live stream. I'm not sure where you received the information about the stream. I actually published 2 live streams. So this today is the first, which is about Terraform basics for Azure. And there will be another live stream next week, so exactly in 1 week, which is about ARM templates basics for Azure, which is just a different approach or different tool set, if you will. And as you can see, the registration was actually open for both live streams, and we have had more than 300 registrations from almost 40 countries, which is, well, superb numbers. All right, but what is this all about today? So the presentation will be in 2 sections. So first, I will talk a little bit about infrastructure as code in general. So what it is, what it means, where it can help, what it actually addresses. So we will not spend too much time there. And then we switch to the second part, which is all about Terraform, how it works, where you can get it, how you can start. And I will also do lots of live demos so that you can see it in action and you have a good and solid foundation to then go from there. All right. Infrastructure as code overview. So what is that term actually meaning? So, well, infrastructure as code is pretty much self-explaining. It means that we obviously manage or deploy infrastructure as code instead of manually. And this is not something new. It's around for a long time. And I also assume that most of you guys already used some sort of infrastructure as code approach, maybe not for Azure, but maybe for on-premises platforms, on-premises applications or whatever. It's really just doing things as code, and it can be as simple as a PowerShell script. That's also kind of infrastructure as code. If you deploy something on your VMware platform, for instance, on-prem, this would also go into the infrastructure as code section. But why are we actually doing this and not just do stuff manually? Well, there's lots of reasons. I will not read all of them here, but well, whenever you do stuff manually, the thing is, it's error prone. So humans are well, they make errors from time to time because filling out a form or something is error prone. So you could have typos, you could think of a different value that you need to enter into a specific field, which then results in something you did not expect, right? Of course, it's also faster. So if you have like a script that automates like a full procedure of deploying something, it will definitely be faster if it works. So if it's a rock solid code, then you're definitely faster. You're more in control because you know whenever you run this script, the result will always be the same. So that means you can test it in a test environment, in a dev environment, in a QA environment before you bring it into production, and you don't have to reinvent the wheel all the time for configuring your infrastructure configurations. So you can really test out everything and then fire it onto your production environment. And it's also more secure because if you do stuff manually, that means that you need, depending on what you're doing, of course, but you need privileges that you as a person, as a human, can do those kind of configurations manually. And as I said, people, well, they tend to make errors. Their accounts could be compromised. They could be, well, tricked somehow. But a script, well, it's also possible, but the script has much more specific permissions. It should only be allowed to do what it needs to do, nothing more. That's very often not the case for humans that have higher privileges. And it's also much more complicated to somehow trick a script if you do things right. That's of course the thing you need to keep in mind. All right, so these are some bullet points why infrastructure as code is a good thing. Now, when we talk about infrastructure as code, there's two basic approaches you should understand because they are different in their nature. And that's the so-called imperative approach and the declarative approach. So when using an imperative approach, and you can see this could be a PowerShell script that you wrote. An imperative script means that you instruct what should be changed. All right, so let's say in line 1, you create, when we talk about Azure now, you create a virtual network. In line 2 or on line 2, you create a virtual machine. On line 3, you create a recovery services vault. And then on line 4, you finally attach the virtual machine to the recovery services vault. And then it's done. So every line is executed on its own, and it's a sequential process, right? Talking about the declarative approach, you don't care what should be changed because you just describe how the result should look like, and someone else takes care how exactly it will get to this result. So all the logic, what exactly needs to be done, lives somewhere else. It's not in your brain, not in your script. It lives somewhere else, in the platform, in the tools. It depends a little bit on the technology that you're using. So you don't instruct what needs to be done, you instruct what you want, and someone will do it for you. So that's a big difference. And when we talk about Terraform, Terraform is mainly a declarative approach. So it follows the principle that you describe how your infrastructure or your application components should look like, and then Terraform takes care how it's actually deployed and configured. All right. Now, what's also very important when we talk to customers or to IT pros, when it comes to infrastructure as code, many people only talk about this specific box here, which is service provisioning, which means when you need to deploy a new service onto the Azure platform, for instance, of course, you have nothing and you deploy a very first version of it to your Azure platform. And then the service is running. And then for many people, the story is over because it's now running. But the reality is that now starts the complex part, which is service maintenance. And service maintenance means your deployed service will not stay there forever, but it needs, or it might need, configuration changes, right? So you might need to add something, add additional components, remove something. You might need to change the configuration of an already deployed service. And of course, you want to make sure, if we talk about infrastructure as code, that this is also done only as code, right? This is the much more complex part compared to service provisioning. That's actually easier. And then the last step is when you, when a service reaches the end of its life, when you don't need it anymore, which means that you decommission or just destroy the service. This again is like a very simple procedure normally. There are exceptions, of course, but normally that's a very simple procedure. All right, but this is very important to understand. If you want to do stuff as code, always think of the full life cycle of your service, from initial provisioning over to the activation or decommissioning of the service. Think about all the different phases life phases of your service. Really address all of them. That's important. All right. Now we already heard that Terraform uses that declarative approach, and we now want to see what Terraform is and how it actually works, and how that declarative approach works. So let's jump into Terraform now. So Terraform is one of the tools from HashiCorp. That's a company that offers lots of different very valuable tools, and Terraform is one of them, because Terraform is their infrastructure as code approach. So Terraform allows you to write infrastructure as code, and it covers the full life cycle from initial deployment or provisioning of a service through service maintenance over to service destruction. It uses a declarative approach, and that now means that you need to understand, how do I actually need to describe how my service should look like. And in Terraform, you have a thing that's called the HashiCorp configuration language, or short HCL. So it's kind of a unique it's their format to create configuration files. It's not something you might already know, such as YAML or JSON or something. So it's their own language that they are using. The good thing, and you will see that afterwards in the demos, it's pretty easy to learn the language and to get started. Of course, depending on the complexity of your service, there's also more complex configurations, sure, but it's very easy to actually start. So that's the beauty of HCL. What's also very nice, if you want to get your hands on Terraform, it's open source and it's free. So there's a free version you can use for yourself or for smaller teams. You actually don't need to pay for it. There's paid versions, or let's say paid features, available. But today we only will focus on the free version, which also means that you can immediately download Terraform now and start creating config files right after this live stream and try it out yourself. Now, one thing that's also very important to understand is the last bullet on the slide is that Terraform is platform or cloud agnostic, which means Terraform can talk to a variety of different platforms and cloud platforms, which means you can use Terraform for using infrastructure as code-based approaches to deploy stuff to Azure or to AWS or to VMware or to your on-premises Kubernetes clusters, or you can use Terraform to configure your Docker environment. It's platform and cloud agnostic, which means it's super open. And this allows you to have this single tool approach to use Terraform to actually talk to all of your different platforms in case you have more of them. And most of us have a bunch of platforms they need to manage, to maintain, to deploy infrastructure or resources to configure those platforms. By using Terraform, you have this unique thing, your unique approach, unique tool that allows you to talk to all of them using the exact same approach. Right, to quickly sum this up, focusing on let's say the hyperscalers. These are like the big three, AWS, Azure, and Google Cloud, and they all come with their own approaches for infrastructure as code. So if you know Azure, you know there's ARM templates that you can use to describe your services that you can then deploy to the Azure platform. Something similar is available for AWS, and the same is true for Google Cloud. But that means if you follow a multi-cloud approach, you need to learn all of these approaches, all of these languages, of these configuration formats, the syntaxes, and so on, because it will be different for all of them. And the beauty of Terraform is that Terraform, because it's cloud agnostic, can talk to all of these platforms. And of course, not only these three, that's important. I think right now there's approx 50 platforms out of box that Terraform can talk to. And if you have something unique that no one used before, you can even write your own provider or plugin to talk to that platform. Of course, then that's a little bit more advanced, needs some development work, but it's very well possible. All right, now how to start with Terraform. So the first thing you need to do is you need to download Terraform from the Terraform website. You can find that on the internet pretty easily. If you don't want to download anything, you can also go to the Azure Cloud Shell, because there you have the Terraform CLI already available. All right. And then you can immediately start writing your first Terraform configuration on your notebook. So that's just the easiest way to start. So write your first configuration locally on your notebook. And then, of course, before you can apply that configuration to Azure, you need to first authenticate against your Azure environment. So you need to somehow log in. That will show you afterwards how this works. You need to log into your Azure platform. Once you're logged in, you can then apply the Terraform configuration to your Azure subscription or whatever you're configuring. So a very simple way to start. Okay. Now the most complex thing in Terraform is, of course, writing the configuration files. And these configuration files, they can contain a variety of different elements that you need to understand. And now to start using Terraform, I think you only need to know about 3 or 4, and these are the ones I put on this slide. There's, of course, many more than just these, but understanding these 4 elements, you can start your journey. So let's cover those. So first is providers. A Terraform configuration can have one or multiple provider blocks. And the provider block is actually used to instruct Terraform, the Terraform configuration file, how to talk to another platform, how to talk to Azure, how to talk to AWS, all the logic, how Terraform will connect to those platforms, how authentication works. All that logic is part of the providers that are described in the provider section. Now I said that the Terraform config can have multiple provider sections, and that actually means that you could have one Terraform configuration file that deploys 3 resources to the Azure platform and another 2 resources to AWS and another one to GCP. in the same configuration file. That's possible because you would specify 3 different providers with all the connection details, and then when you apply the Terraform configuration, all the platforms would actually get their resources as described in your file. All right, then the most important element type is resources, because this is where you describe what you actually want to deploy. Now, when we talk about Azure today, everything you deploy in Azure is a resource. So, for instance, a virtual machine, a virtual network, a database, a SQL server, whatever you pick from the marketplace, it will deploy resources. And a resources element describes the resource type you want to deploy and the exact resource configuration you want to have. Let's say, what region does this resource go to? What name will this resource have? And then, of course, depending on the resource, all the detailed configuration, how you want the resource to be configured once it's living in Azure. And the resources elements can also contain dependencies, because if you deploy a more complex service, you might have resources that are dependent on each other. And then, of course, you also need to instruct Terraform how this dependency works for your application. So we'll see that in a bit when we go to the live demo. Then also a very important element is variables. Variables allow you to parameterize your deployments. Let's say you have a configuration file that deploys a web application with everything that's needed for this web application to work. If you have this code ready, but all the names of the resources, all the configurations of the resources are hard-coded, that would mean that you can never use the same code in a different environment, maybe, or maybe even in the same environment, because you would first need to change some parts of the code, change the names, change some values, and this can be very complex. So using variables allows you to parameterize your deployments by defining variables that you submit values for during deployment time, which means you might have a configuration file that deploys a virtual machine, and you have variables that you can submit for the virtual machine name and the virtual machine size, for instance. And then when you deploy your Terraform code, it will actually ask you, well, okay, tell me where this machine should go. Should this go to the Switzerland region or to the Western Europe region? And what should the name of the virtual machine be? Please enter some name. And then it will deploy that virtual machine to the platform. And if I use the exact same code tomorrow again, I could submit totally different values, but the code in the backend would be exactly the same, and the result would also be exactly the same. The only difference, of course, would be the variable values that we submitted. So this gives us much more flexibility, and we can bring the same code to different platforms and easily change variable values depending on our needs. All right. Now, how does this Terraform process looks like? So after you download the Terraform to your box, you can now start writing one or multiple configuration files. So what does that mean? Whenever you have a Terraform config file, this config file uses a specific extension, which is .tf for Terraform. And for very simple configurations, you might always have maybe one file, which can have some name, for instance, main.tf, main.terraform. If you have a very complex configuration you want to deploy that maybe has, I don't know, 500 lines of code, then it could help to somehow fan out and split this code into multiple files that are easier to read for you. And the cool thing about Terraform is if you run Terraform, it will automatically collect all the different TF, so Terraform files that live in the same directory, and will merge all of these files for you. So that means you can decompose your complex configuration to multiple files, but you don't have to worry about merging them before you apply the configuration to your platform. Terraform takes care for you. So for these demos here, we will only work with one file for most of the demos, and then switch well to a demo where I quickly show how you could just use multiple files. So we will see it's a very simple thing. Then once your config files are ready, you need to start a Terraform command. That's the first time now you run Terraform, and this is Terraform init. So we initialize the Terraform deployment, and what init does, it reads all our Terraform configuration files in our directory, and it analyzes what types of resources you want to deploy to what platforms. So init will recognize, hey, wait, this configuration file should deploy a storage account to the Azure platform. And it also deploys an S3 bucket to AWS, for instance. And it will then know, okay, if I need to deploy something to AWS and to Azure, I need to first download the plugins for these providers. So for the Azure provider and the AWS provider. And this is what happens in this phase. When you run Terraform init, it will scan what providers and plugins do I need to download, and it will download those plugins directly from the internet. That's just like the simplest approach. And we'll have that available on your box afterwards. Then once the plugins are there, we can go to the next step, which is Terraform plan. So that's the next command we execute. And Terraform plan now reaches out to the different platforms to see, well, what's living out there? What do we already have on our Azure platform? And what is the person running Terraform plan? What does this person want to actually provision or manage? And we'll then create a plan that tells us, look, if you would now apply this Terraform configuration that you wrote, so your Terraform config file, if you would apply this to your Azure platform, this is the changes that I would execute. And then it will tell you, okay, depending on what you want and what's already living on the platform, I would do this. Saying I would deploy a storage account, and this storage account would have that name, and so on. And this is very important because that allows me to understand what would happen before it actually happens. So it's like a safety net that tells me, look, this is what I would do. Please make sure that this is what you expect. If it's not what you expect, you better go back to your configuration and fix it. All right. But if you're happy with the plan, you can then go to the last stage, which then means, all right, the plan looks good. This is what I actually want to achieve. So now please apply this to the platform. So apply the Terraform configuration to that Azure platform or wherever it should go. And then it's done. And then it's done, and you apply your first Terraform configuration. All right, now before we go into the demo, one last slide, because this is something very, very important when we talk about using Terraform. It's a thing called state. So there's this thing called Terraform state, and Terraform state, you can imagine imagine it's kind of a database. And in that database, you can see what resources from your real world platform, so from Azure, which of these resources are under Terraform management. So what did you deploy using Terraform? All of that information is living in the state file. And you can think of it being like a connection point between the Terraform configuration resources that live in your configuration file and the real world elements or resources that live on Azure. Because you will see in the demo afterwards, in the Terraform configuration files, we use internal IDs, but these IDs are only used within Terraform. So nor Azure, nor GCP, nor AWS, they know anything about these IDs, because all of these platforms, they have their own IDs for their resources, right? And there needs to be a way where Terraform knows, well, what Terraform resource ID maps to what real world or platform ID of the specific platforms. And this is what state is. And that makes it a very, very critical thing, because once you deploy something, your state file or your state database will be updated, and whenever you touch the same resources the next time using your Terraform configuration, you need to have the state file at hand. If you lost it, you created a mess and you need to first somehow fix this. It's solvable, absolutely, but it can be a lot of work, especially for complex configurations. Now, the second thing is the state file might contain sensitive data, such as pre-shared keys, or maybe, depending on the service, even passwords. So it's a very, very critical file. And because of these two things, because the state file is very critical from a sensitivity perspective, but also from the perspective that you need to have it all the time, you manage your resources that are under Terraform control, it's not a good idea to have the state file locally on your notebook, because that would mean only you as a person has access. Whenever another person of your team tries to manage infrastructure that you deployed, he will not have access to your state file, and then it will create a big mess. If it's just for you, then of course it's perfectly fine. But even then, I would suggest to remove that local state file. This is the default place where it's actually stored, so on your notebook or wherever you execute Terraform, and move it to a remote place. So you can instruct Terraform to store the state information remotely. For instance, Terraform has its own cloud solution, which is a very nice and slim solution to store your state files. And of course, not just that, there's more than just storing state. Or you could use something as simple as an Azure storage account and instruct Terraform to store states there. And whatever you use as a remote backend or remote state, when you now hand over your Terraform config files to one of your colleagues, and the Terraform configuration file points to that remote state, it will also work for your colleagues, right? So that's a good thing. So keep state in mind. This is very important. All right. So now let's jump to the demo, where I'll show you a little bit how Terraform works in the real world. And that will start from zero. So with an empty config file. Actually, I don't even have a config file. So I'll start by creating the config file. So, but first, where can you get Terraform? If you just Google or Bing and search for Terraform download, you will see there's all the downloads you need to install Terraform on your box. Or as an alternative, as I said, go to the Azure Cloud Shell, then you don't even have to install it. So for this demo here, I downloaded Terraform to my Windows box, and I will use it directly from my notebook. All right, this is my Azure platform. As you can see, well, I narrowed the view a little bit down to just one subscription, and in there you can see one resource group. This is not of interest for now. We'll take a look at that later, but this is all I have. So one resource group, and all the rest is empty. Now I go to my favorite editor, and for my case, that's Visual Studio Code, but you can use anything. It doesn't really matter. And I created a folder called Terraform Demo 1, and as you can see, it's totally empty. So I will now start creating a new file from scratch, and I will just call it main.tf. Now, because I use this a lot, of course, you can see it already has this nice Terraform logo. This is just, well, to make it look a little bit nicer. It's not really needed, so you could also write this in Notepad if you want, but you will not be very productive, I guess. So in Terraform, in Visual Studio Code, you have different Terraform plugins that help you to very quickly create a configuration file depending on your needs. All right, so now, as I said, to start writing my configuration now, I would add a provider section. So I just write, well, provider, and I define the provider I want to talk to, which is Azure RM, which stands for Azure Resource Manager. And in this block, I could now add different configurations, how exactly I want to talk to the Azure platform and so on. For now, just keep it simple. I just leave this empty for now, so I don't configure anything. So, but this is just for the records. In here, you could actually configure how your connection to the Azure platform actually works. You could use this for authentication purposes, for instance, and so on. But for this demo, I will just leave it blank. And now I want to create my first resource or describe my first resource. And for this, I use this resource block or resource code word, if you will. And of course, Terraform uses predefined keywords for that then translate to the different Azure services. So when it comes to Azure resource groups, and that's actually the first resource type or the first resource I want to deploy, this would be Azure resource group. So I instruct Terraform, please, I want to have a resource of this type, Azure RM resource group. Now, of course, when you start using Terraform, you have no clue about these these names and everything. You can find all of this in the Terraform docs. So there's a very nice documentation about all of these, how they can be configured and so on. Everything is perfectly documented. All right. Now, because I could have multiple resource groups in the same configuration file, I now need to define the Terraform internal ID of this first resource group, and I just name it RGR1. Again, this can be anything. And then the block starts. And now I need to configure my resource group. And if you ever deploy a resource group onto the Azure platform, you know you need to submit two values. So one is the location. And for now, I just pick West Europe. And second is the name. And for that, I just pick demo1. And that's all the values I need to submit to hopefully and successfully create a resource group by using Terraform. Now, of course, you can format the configuration file a little bit nicer. So what we normally do is something like this to align all the values so that it's easier to read. So in here, you're pretty much flexible. Now, finally, I saved the file, and that's actually my very first demo. I want to show how you can now deploy this to the Azure platform. Now, of course, remember, I'm sitting on my notebook. I never talked with Terraform to the Azure platform. And again, I'm totally disconnected. I'm sitting in Switzerland and I want to deploy something to Western Europe. So I need to now first somehow authenticate against the Azure platform. And there are several ways to do so. So if you use Terraform interactively, like I do it now in a very simple way, you could use different ways to log in manually to the Azure platform. So for instance, I could just use the Azure CLI to log in. So I'll quickly do this because that's just the simplest way. Of course, maybe later you would use another approach, maybe by using a service principal. But for now, I just use my account, use that one. And now the Azure CLI is already connected. You can see I'm logged in into Azure. And Terraform can now use this, this token to authenticate against Azure as well. So I'm now connected. All right, now I need to start Terraform for the first time, the Terraform CLI. If I have no clue how this works, I just start Terraform without any additional commands. And this gives me like the help file that tells me, well, look, there's the different commands. You can apply stuff, you can destroy stuff, you can get stuff, and so on. So lots of possibilities that the CLI offers. We will only focus on maybe 2 or 3 today, but on the most important ones. So let's do for now, as we learned from the slide deck, the first thing I need to do always is Terraform init. And now what you will see here in this folder, demo1, it will create another folder and download the Azure RM plugin, because it already analyzed my file and it found out, well, okay, you want to deploy to Azure, so I will download the Azure plugin in here. It's an exe file, and now it's available on my box. I don't have to take care about any details of this. It's now just sitting there. This is a versionized plugin, as you can see there. Oops, I'm sorry. 223, which also means that you can instruct Terraform what plugin versions you want to use, what provider versions you want to use to talk to your platforms, and so on. If you don't specify anything, we'll just pick the latest one. And now once this is ready, I can now do a Terraform plan. Now this reaches out to Azure, to first find out, well, what would now happen if this configuration would be applied. And as you know, because I've just shown you, there is no resource group living in my Azure environment with the name demo1 in Western Europe. So this should now bring back the information that hopefully Terraform would have the plan to create a new resource group with the name demo1 in Western Europe. So let's see if that is true. All right, so I can now see the plan. This is like the summary. I can see, okay, 1 resource will be added, 0 will be changed, and 0 will be destroyed. This is obviously what we expect. And if I scroll up a little bit, I can also see the details. And it tells me, okay, this will be created. This will be the location. This will be the name. And it shows me, well, plus, plus, plus means, well, this is created newly from scratch because it never was there. All right, and if I'm happy with that, because this is exactly what we expected, I do a Terraform apply now, and this again does a plan. So this includes the plan phase as well. So it will do the same thing again now and show me exactly the same plan. But then it's up to me to decide, do you want to apply this now, yes or no? So let's wait for a second or two, and then we'll give this a try. Shows me the same information. Are you sure you want to do that? Yes. And now Terraform starts talking to Azure and will instruct Azure, please create a new resource group with that name in that location. Take some seconds and then it will be there. Now maybe you recognize in my folder here, a state file has been created. All right, so because we did not configure Terraform to use a remote state or something, that state file has been created locally, and I can now see what information that is in this state file. So I can see basic information about the Terraform version I used. I can see what resources I deployed. Now, for now, I only have 1 resource of type resource group. It's managed by the Azure RM provider, and then I can see the details. And this is very important. I can see the ID that is used to work with that resource on the Azure platform. So this is Azure specific, and this then translates to our internal Terraform ID we defined for our configuration file. So this is very important to have this mapping, but Terraform does this for us. All right, and I can see the summary. Resources, 1 has been added, 0 changed, and 0 destroyed. No surprise. So let's quickly see if this is true. If I just refresh, I can see demo1 is now there, and it's just an empty resource group, so nothing special. All right. Now, when I said, well, don't only think about the initial provisioning, but also the service maintenance. I want to come back to this now, because if I reopen my configuration file now, this resource group is now productive, right? And now maybe I find out, well, I forgot to configure specific settings. I didn't do that, but I don't want to remove the resource because it might already be in use. I just want to change the configuration of the existing resource. Now, a resource group doesn't offer too many configurations, unfortunately, so I will do just a very simple config here. I will add tags, but I forgot to add tags, for instance, and I want to add a tags section as well, and for instance, specify, well, I want to have an owner tag, and the owner of this resource group should be Marcel. So something like this. I save this file and I do another Terraform apply. Now what to expect here? I did not instruct Terraform, hey, only change the tags because the resource group already exists. No, I just said, I want to have a resource group with that name, with that location, and that owner tag. And now Terraform takes care of finding out, well, is that already existing? And if so, what configuration does this resource group actually has? And now, if everything works as expected, we should see that nothing is added because the resource already lives in Azure, but it should find out, well, I need to change one of the resources. So one resource that are described in your config file will now be changed. And if I again scroll up a little bit, I can see here, based on this icon, okay, this resource will be changed. So this sign indicates a change. Then I can see, well, ID, location, name, there's no change, but tags, there's again a change. And then I can see, oh, the owner tag would be added. This is exactly what we wanted. Do you want to do that? Yes, I'm happy with that plan. And then after a second or two, this will be done. So this should be pretty quick. If I go to tags now, it's not yet there, but in a second, we should see that tag as well. And very important, it did not delete and recreate the resource group. It just changed the configuration of the resource group. Yeah, still not there. Let's wait another second. Let's quickly verify if it executed correctly. You never know. Oh, it's still working on it. Now it changed. Good. Go back. Refresh. Tags. And now you can see the owner is finally there, and Marcel is now set as the owner. If I would not change this, just as an information, if someone doesn't follow the process now and thinks, well, I will change the owner manually. I want to skip this code thing because I have no clue how Terraform works. I will just do things manually. Now you go back to your code saying, all right, so Marcel is still the owner. That's fine. Now let's add a cost center, a second tag to this, which is 333, and now apply this. Again, now what happens is Terraform should recognize, well, cost center is a new setting in the configuration file that's not living yet out there in Azure. And it will also find out, hey, wait a second, the owner should now be set to Marcel, but the current value is something totally different. And with that, you can also find out configuration drift, saying, well, did someone change configurations or part of configurations manually because he didn't follow the process? So let's see. It takes a while, but should very soon come back. Yeah, there we are. And now you can see it would add cost center, and it would change the owner from the current value to this new value, because of course my configuration file will now overwrite the existing value that someone changed manually. And of course I want that because I want my code to be what's living in the real world. That should be the same. And so that value will be overwritten now. All right, so very simple process how you can change the configuration afterwards. Now let's pick maybe another example that I don't type myself. It's a little bit too much code. If I want to add a new resource now, an additional resource, I will add this code block. So again, another resource section here. I will now define, well, I want to deploy a storage account. Again, I use an internal ID. And now, of course, you can see that some of these parameters will be the same, like the name and the location, so same as for the resource group. But then there's, of course, service-specific information, such as, well, what resource group does this storage account need to go to? It's demo 1, that's the one I provisioned up here. And then what's the replication type and tier and so on. All right. Now, one thing to remember is this. Every resource needs to go into a resource group, and I defined here the name demo1 as the resource group this resource should go to. If I would apply this configuration, this would perfectly work. But if I would delete everything that has been provisioned and redeploy this, it might fail, because depending on this configuration, Terraform does not know that this is the same as this. So it doesn't understand that it needs to deploy the resource group first and only then deploy the storage account. It doesn't understand this. And there's two ways to change this. Even I can add an explicit dependency saying, well, this configuration here depends on the resource above, or Terraform supports something very nice, which is called the implicit dependency, which just means instead of adding the value here manually, I can just reference to this name value up here. which would then look like this. I just define, well, I want to reference to one of my Azure resource groups I have in my configuration file. Now, because I can have multiple, I need to reference which one I'm interested in, RGR1, and then I will pick the name property, and this will be the value I want to add here, which means it will pick demo1 from up here and use it down there. And again, this not only just takes the same value, this also gives Terraform the information, this resource up there, the resource group needs to be provisioned first before you can provision the storage account. And with that configured, I don't have to worry about creating an explicit dependency because Terraform already knows. So if I would do Terraform apply now, same thing, it will recognize, okay, I need to deploy a new storage account. And that would finally be it. All right, so now time is running out. Let's see what else I will show you. I will not do all the demos because of timing issues. Let me maybe, just pick one more. Again, I mentioned you can split your files into multiple different files, and Terraform will merge them on its own. You can use variables to really parameterize your code, because this, of course, is very bad code to have all of these values hard-coded. You should never do that. So really work with variables. I will just give you like one very simple example. So for instance, I could define a variable up in my code. So variable, I can give that variable some name, for instance, location, if I want. And then I can have a variable block with a description saying, well, what is this? This is, for instance, the Azure region. All right, and then instead of using a hard-coded value down here for the location property, I would then say, well, just pick the value that this variable has, location. There we are. And then maybe the same is true for the location down here. All right, so let's save this. I will skip this now. So I will not provision it. I will apply again. And now, of course, Terraform will ask, well, you have a variable that you need to submit a value to now, which is the Azure region. Please give me a value for the Azure region. Now I can enter it manually, or of course, if it's multiple variables, I could also have all of these variables in the variable file that store all my variable values. So this makes it very flexible. So but now again, I will skip this because it's always more or less the same procedure. I will remove that again. I will quickly, well, go back and that variable again so that we have exactly the thing that we provisioned. All right. Now the very last step I want to show is, let's say this is a demo thing I showed you now. And this is a service or a configuration you don't need anymore. You can also destroy the service. There we go. And with that, you instruct Terraform to delete everything that is configured in this configuration file, that is described in your configuration file, and it will actually remove everything. But again, it does a refresh first, it is a plan, and it will tell you exactly what gets destroyed before it actually destroys it. There we are. Tells me, well, I would destroy one resource. No surprise, it's our resource group. All of these values are lost. Are you sure you want to proceed? Yes, please. And then the resource group is gone. So that was a very quick demo how Terraform works, how you can start writing your Terraform configurations, how you can apply them to your authenticated Azure platform, how you can then update configurations that are already existing out there, and how you can finally destroy existing Terraform configurations if you want to decommission a service or just remove whatever test resources and so on that you don't need anymore. All right, so going back to the slide deck, to close the session, I want to quickly sum up what Terraform is, the most important things to take away. A, Terraform follows a declarative infrastructure as code approach that allows you to describe your infrastructure, to test the configuration files in your test environment until you are sure it's rock solid, and then bring it to a QA or production environment, and you can be sure that the result will be exactly the same. Terraform supports a full life cycle of a service, so from initial provisioning over to service maintenance, where you can just change the configuration of an existing service. What's important to understand there is, depending on the platform, of course, there's some properties that you cannot change after they have been set. So for instance, now in my demo, I couldn't just change, for instance, the name of that resource group. I would need to destroy it and create a new one. But for certain properties, you can definitely change values and change configurations of your services, but it's not supported for everything. Of course, you need to understand the platform you talk to and what the platform actually offers and allows. And finally, Terraform is an excellent way to talk to Azure and start your infrastructure as code journey. But it's not only for Azure, it also works for other platforms. So if you want to talk to AWS or VMware or Kubernetes or something, Terraform is your friend too. You will just need to understand the specific providers, how they work, how the resources work and are constructed. Normally that's all very well documented. And then you have a very nice start using Terraform. All right. That's it from my side. That was a really quick run through, but I hope this gave you some inputs what Terraform is, how it works, and you are now fully motivated to try Terraform out yourself. So I really encourage you, go downloading Terraform now, right after the session, and start playing with it. You will find lots of docs out there. There's some stuff on my blog as well that gives you kind of a kickstart when it comes to Terraform. So also make sure you read that. And with that, I'd like to thank everybody who attended the live stream, and I will still be here to answer questions in the chat window in case there is something. Thank you very much, and hopefully see you next week when we talk about ARM templates basics for Microsoft Azure. Thanks a lot. Thank you. Bye-bye.